Hello, in this example, we are looking at second example of Bernoulli. So in the last video, I went over the first example of Bernoulli. So make sure, please watch that where I define what is Bernoulli and I did one example. So let's continue. So here is not exactly in the correct format. If you remember, the correct format is y prime plus py equal to q times y to the power n, where p and q are function of x or function of t, whatever we are using, and n is not equal to 0 or 1, because if n is 0 and 1, then it is simply linear and you can apply linear. So here you can simply multiply out, and let's see what I get. Y prime equal to x y to the power 4 minus y. So I can bring this negative y to this side. I'm adding y to both sides. Y prime plus y equal to x y to the power 4. Now if we compare with this, it is indeed Bernoulli. So here the p is equal to 1, q is equal to x, and n is equal to 4. And remember, the substitution that you need to make is v equal to y to the power 1 minus n. So let's do that. So I'm going to make the substitution v equal to y to the power 1 minus 4, because 4 is the n. So I get y to the power negative 3, or 1 over y cubed. So at this point, we take the derivative of both sides with respect to x. So remember, y is a function of x. So at the end, v is also a function of x. So dv dx equal to, I'm going to start from here, negative 3 y to the power negative 4. Remember, n x to the power n minus 1, right? So the derivative of x to the n is n x to the power n minus 1. Of course, we're using y here instead of x, but y is a function of x, so you multiply by y prime, or dy dx. It's the chain rule. So let's solve for dy dx. Again, the y prime and dy dx is the same. We use the prime notation, or dy dx is the same. So let's solve for dy dx. So we're going to multiply both sides by negative 1/3 y to the power 4. So let's continue. So let me write this one first. Now, of course, negative 3 and negative 1/3, that is just 1 when you multiply. And y to the power negative 4 and y to the power 4, that's y to the power 0, which is also 1. Remember, when you multiply, you add the exponent. So only thing survive on the right is dy dx, because that is your goal. You solve for dy dx, and that is the reason you multiply by the reciprocal, right? So the opposite of negative 3 or reciprocal is negative 1/3. and the reciprocal of y to the power negative 4 is y to the power 4, right? That is the reason. In this side, I'll just copy it. Now at this point, you simply substitute this in place of dy dx. So that goes in place of dy dx. So this goes in place of here. So let's do that. So if I replace y prime by negative 1/3 y to the power 4 dv dx plus y equal to x y to the power 4. So all I did, I replaced y prime by whatever my y prime is, right? Once you do that, the next step is to make the coefficient of dv dx 1. So I have to make this coefficient 1. So how I do that? Well, you have to multiply both sides by the reciprocal of that, right? So let's do it. So let's multiply both sides. So let's multiply both sides by the reciprocal of this, which is going to be 1/3. So let me write here. So the negative, so the reciprocal of negative 1/3 is 3, and then reciprocal of y to the 4 is y to the negative 4. So I'm multiplying both sides by 3y to the negative 4. So when I multiply this out, so this will be simply dv dx, because 3 times y to the negative 4 and negative 1/3 y to the 4 will just be 1 when you multiply, plus 3y to the negative 4 times y is 3y to the negative 3, because remember there's invisible 1 here, and when you add you get negative 3. So negative 4 plus 1 is negative 3, equal to, let me just multiply out, I get 3x, because again y to the power 4 and y to the power negative 4, that is just 1. So only thing you have is 3x. At this point, look at the relation between v and y. If you look at here, v is in fact equal to y to the power negative 3. So I can replace y to the power negative 3 by v, because v is equal to y to the power negative 3. That is what we start in the beginning when we do the substitution. So let's go ahead and do that. So I'm going to continue down. So let's continue. So I have dv dx plus 3v equal to 3x. So at this point, there should not be any y. And this is a linear equation in terms of v and x. So at this point, there should not be no y. And this is a linear in terms of v and x. So here actually the unknown function is v. So it's a linear in terms of the unknown function. So we already know how to solve linear equation. So here the p is 3 and q is 3x. So don't confuse this p and q with whatever p and q I denoted here, because this is the p and q for the linear. So don't get confused. We did not really use this p and q for the Bernoulli. We just wrote it down, but it's not really in use. So let's do that here. So I'm going to write P equal to 3 and Q equal to 3x. So let's find the integrating factor. U is e to the power integral of P dx. So in this case, it's going to be integral of 3, which is of course e to the 3x. Do not add any c. We just choose c to be 0. So the v is going to be equal to, remember the formula, something over something. So on the top is the integral of u times q, and the denominator is u. So let's do that. I'm going to substitute u in place of u, and I'm going to substitute q in place of q. So let's do it. So maybe I can do it down here. So I get v equal to integral of e to the 3x times 3x dx over e to the 3x. So here on the top, I have to use the integral by part. So let's do that in the side. So let's do that integral. Let me write 3x in the beginning, and I'll do it fast because you already have many example, and hopefully you remember. So this is the integral by part. So let's do that. So u is 3x, dv is e to the 3x dx. Here you take the derivative, du, the derivative of 3x is 3 dx, and the integral of e to the 3x is 1/3 e to the 3x. So let's apply uv minus integral of v du. So if you do that, uv, so that's u by v is 1/3 e to the 3x. So uv minus integral of v, which is 1/3 e to the 3x, and du is 3 dx. So this 1/3 and 3 just 1. Here this 3 and 1/3 I can cancel, just 1. So I have x e to the 3x minus the integral of e to the 3x, that is 1/3 e to the 3x, and then plus c. Here I have to add c. So this amount, this one goes here. So let's do that. So my v is equal to, I'm going to copy that, divided by e to the 3x. So I'm going to distribute e to the 3x under each one, and we have to simplify as much as possible. And also I have to replace v by what is my v. So let's go back and check. My v equal to y to the power negative 3. So let's do that. So I'm going to replace v by y to the power negative 3 equal to, and I'm going to distribute them. So x e to the 3x, I'm going to actually show when I distribute. Very good. So if I rewrite this, I'm going to cancel. So I can do some cancellation here. So I end up with y to the power negative 3 equal to x. So all I have is x here minus 1/3. That's all I have here, plus c e to the power negative 3x. I can just move it on the top. And that's it. You can leave the answer like this. That's your final answer. This is not explicit, it's still implicit, because explicit means y equal to in terms of x. If you look at carefully on the left, it's not y, it's y to the power negative 3. So we're just going to leave it like this, and that's enough. Always remember, believe in yourself and you can do it. Thank you. Bye bye.